Did you know that the coldest spot in the universe is here on Earth? Let's talk about the Bose-Einstein Condensate. The lowest temperature in outer space is 2 Kelvin, or minus 271 degrees Celsius. But lower temperatures can be achieved on Earth, approaching the universal limit and deep in the quantum regime. The Bose-Einstein Condensate is also called the fifth state of matter, and it can only be produced in a well-controlled and isolated environment, for example in a laboratory. In an apparatus like the one shown here, the atoms are cooled down in the glass cell. In order to understand how the cooling works, let's consider an atom with its corresponding electrons. The interaction between the atom and light, which is responsible for cooling, will depend only on what happens to the outermost electron, meaning the valence electron. To make a Bose-Einstein condensate, usually alkali metals are employed, which are the atoms on the first column of the periodic table. This is the case because since these atoms have only one valence electron, everything that happens to the atom will depend solely on the state of this electron. In the first stage, the atom interacts with light, which slows the atom down, meaning that its kinetic energy and therefore its temperature decreases. This is possible due to a process called Doppler cooling. After some time, Doppler cooling reaches its limit, meaning that you cannot cool the atom further down using light. At this point, another cooling method is employed, which is called evaporation. At this stage, the atoms collide and we let escape the ones that have the highest energy, meaning that you lose some atoms, but at the same time you cool down the sample significantly. Eventually, a phase transition is achieved, meaning that the sample goes from a gaseous state into a condensate. This condensate has a temperature of roughly 10 nanokelvin, and it can be thought as a giant atom or a superatom because all the atoms that compose it have the same quantum state and they behave as a single one. The beauty of this process relies on the fact that initially the atoms behave as particles, meaning that we're in the classical regime, and further down during the cooling process, the atoms start behaving as waves, meaning that we're in the quantum regime. This way, every time a Bose-Einstein condensate is made in a laboratory on Earth, the coldest spot in the universe is generated. Here we can see a map where the laboratories that work with Bose-Einstein condensate are marked. So next time you want to surprise somebody, tell them that the coldest spots in the universe are here on Earth.